I haven't done my presentation yet, so I'll be talking about the scaling down on Qt. I'm a product manager in the Qt organization. I'm based in our headquarters in Finland, and we have engineering in our site in Oslo, in Norway, in Oulu, in Finland, and in Berlin here. And if you ask my family, they think I work in the airport. But today the topic is about the scaling down, how to make Qt nice and small. And I'm looking at this from the kind of a market trends point of view, what's happening in the market, what do we see as our customers requesting and happening on the Qt side. Then I'll be covering, something that we already have out-of-the-box experience when you download the latest Qt and what do you get out of that. Then I'll be covering the specifics of the Qt and how we are approaching that through our professional services offering. So that'll be the 30 minutes, more or less. So going into the market trends. Bigger phrases, that's a trend word being used in the industry. Faces are the UIs, the displays, the UIs of the application. So that's the face of the application. And these faces are coming all over in different kind of machines and technologies that previously were hardware-based interfaces. And the user experience expectation is super tough for manufacturers because users approach the world of touch and color interfaces from the exception of using them similar way as mobile phones. And mobile phones are super fast, super responsive, and super expensive. And then consumers want to have the same kind of speed and performance on their toaster or whatever is the machine that will have the interface. So that's very tough for manufacturers, and also for us, working on this, creating the enablers for our customers. It also means that, and there's plenty of free seats here, those by the door, so come over. What is also happening is that the manufacturers who are working on this space are now, the old competencies may not be valid anymore because they had people who know everything about the knobs and bolts and sliders, the physical pieces. But now those are kind of going away, and in return, the software engineering are building these knobs and sliders and switches for their solutions. And it's totally different way, different kind of competencies and different way of approaching. So there are some challenges for this transition on the traditional hardware makers to turn into something which is a software maker. So the challenges are in around how to build the user experience so that it's good, it's intuitive, and it's fast and responsive, but also like how do you focus on the bill of material when you maybe should be focusing on the user experience instead. So this is a big trend that we see. Another big thing that we see is the low-end hardware, what used to be the MCUs and the LCD displays with monochrome UIs, the low end is getting more and more performant. And then what is the traditional Cortex-A side of application processors and embedded Linux, the hardware of those machines are getting lower and lower in bill of material. And these two worlds are getting really close to each other today. And from that point of also, it's also very logical for us in the Qt to start looking into the high end of the MCU world when we already cover the low end of the Cortex-A world quite well. So that's what's happening on the market. And then sort of a last of the market reach, so there are three main factors that are often driving our customers and the implementation of the solution. So the first one is that they want to make products that are desirable, people want to buy, they can sell and make money and earn, and they want to use the technologies to enable that. The available technologies may not be there or are there, but then there's a business gravity for time to market or the bill of material or the cost, so they need to be able to build that in an affordable way. And the way we look at creating our enablers and creating the support for the hardware and enabling the graphical accelerations and other bits and pieces that are required for products is that we need to find the sweet spot so that our customers can really thrive between these different three main drivers. So now looking at what you already get out of the box with the Qt today, so with the 512. So we have a very good coverage of Cortex-A world, the application processors in the world. So we support the high ends of the embedded targets, and of course, obviously desktop. So I'm kind of like not mentioning the desktop because the embedded is the topic of the day. With multiple different screens, multiple different UIs for single applications or systems. We have a very good mid-range support, and currently the low end in the Cortex-A world is considered the IMX7s, IMX6 ULL. I've been told that anybody who can sit can stay, anybody who stands has to leave. So there are 3 seats here.
Please take a seat. Everybody has no seat. Must be.
Yeah. That is the rule. Okay. Something else what's coming out of the box is not the seats with the Qt, but very good support for different Cortex-A type CPUs and platforms. We have also had the concept or the project for what we have called Qt Lite, which is the project and the concept for being able to configure not the whole Qt to go out with your solution, but some parts of the Qt. And the big new thing in the 512, which was out today, if you haven't downloaded that yet, you can download it now, is that with the Qt configurator, you can create the kind of configurations that can be used with the embedded Linux. So that's a super good thing for the embedded Linux users. And we have spent quite a lot of focus on making Qt faster, making it more nimble and smaller already. So there's a big jump in Qt 5.9, and there has been incremental improvements on different releases after that. So now going to the beef, what you wanted to hear about the MCU. So for me, MCU is the ARM version 7, the Cortex-M4 and Cortex-M7. So we are not looking into lower side of the MCUs. And currently we have 2 demos, where we have the demos. There's an NXP 1050 and an STM32F7. We also have an STM32F4, but we just didn't carry it here because it looks exactly the same. So these are the focus for the MCU support today. Now, we do sell the service, the MCU as a service for the customer, and this is one of the reasons why we do that, because it really depends on what the customer wants to do. What is the operating system and what are the bits and pieces we need to put into the device under Qt to make things happen. So if a customer only needs the display, and you don't need threads, and you don't need touch, you don't need any of the other hardware connectivity, then we can do just bare metal support on the Qt, and Qt will be very small and nimble. But if you need the file system and videos and audios and networking and all the bells and whistles, then by far the quickest time to market is using the RTEMS, which is the operating system we currently use. So this is one reason why this currently is a service and it's a custom work with the customer. Also, if we think of Qt features, so we have the widget UIs running, we have QML running. QML has some limitations. There are some parts of the QML that are quite heavy, so if you want to use shaders, creating the shadows and the shaders on the fly with QML, you will end up spending a lot of CPU, so we'd currently advise you not to use that particular little feature on the QML. We do support the full internet realization. We do support text inputs, text rendering, true type fonts. That's also memory-wise very expensive. So if you can do with pre-rendered text, you will save a lot of memory. And then TCP/IP connectivity. What's under work is the developer workflow. So how do we integrate this to the creator and to the rest of the Qt tooling? So how it works today is that it's a command line typing and tinkering. And understudy is a 3D. We have a few requests from the customers to use 3D on the MCU. Looking at it today is that the performance may not be what we or the customer actually want, so the 3D elements are excluded at this moment. And then, of course, there may be limitations, as on the previous slide, set by the operating system or the hardware, that if you want the connectivity, you need to have that on the underlying layers before we can support that on Qt. Then looking into the memory consumption. So today, Qt will require external memory. So on the MCU architecture, the discussion is typically on the internal memory and external memory. The CPU has internal memory from a few hundred kilobytes up to 2 megabytes. And then there is external memories, which are typically bought in chunks of 8 megabytes. So you buy 8, 16, and so on the memory. So we do require external memory today. The display resolution and then how that is rendered on the screen has a big impact on the memory requirements in the system. But currently, we have been looking into widget-based applications. We can run under 4 megabytes of RAM. And that's a very small widget application. If you make really big widget application, of course, it will require much more memory. With the QML-based applications, the e-bike demo you can see on the stand takes about 10 megabytes. And then the wearable application, which is the smartwatch type QML application, takes about 8 and some megabytes of RAM currently on the hardwares. So that's where we are currently with the implementation. Then looking into the professional services, because we are selling this MCU offering as a professional service. And we do, of course, professional services for other than MCUs also. But if you look at the customer project, the real customer project from a customer perspective, these different colors are different vendors. So they have hardware vendors, operating system vendors, firmware vendors, Qt, the framework vendors, somebody doing some consulting on some parts of this or all of this, and so on. So it's quite a lot of project management on the customer side. What we can do as a service is that we actually take the ownership of all these bits. So the whole firmware and the operating system and the Qt integration, you can get as a service as one thing, and it's integrated then with your host environment, and it comes with the tool chains and the deployment tools and all of that. And especially, as I mentioned earlier, that with the hardware companies who used to have competencies on knobs and sliders and the physical switches, they look into the hardware work, and we start talking about the debugging bridge and the tool chains, it gets difficult. So we can really help on this area. Also on the embedded Linux sides, where the Yocto recipes are super flexible, but super badly documented, so they really need competencies and expertise to build those. So that's something that we can deliver as a service. And especially on the MCU side, this is the baseline service that we are doing. We can also do, and this is what the boot to Qt is. So if you've been thinking what is the boot to Qt? So it's a feature. We pre-made these environments as part of the delivery. So when you are downloading the creator and you say that I want this hardware and that hardware and this hardware, that's actually what's in there on the tooling side and for the device that you are having. Then, because we have been involved in a lot of these projects, we are doing consulting for the customers to say that, if you really want to run that video that way, let's make sure that you get at least this much of memory and at least this kind of GPU, because otherwise you will not be successful in aiming. You want to have minimum 30 frames per second. So one of these requirements is INC compliant unless you get this hardware. So we have this kind of expertise and knowledge we have seen on different projects, and we can help in there. And that's also another actually pitfall of the number one failures that we see on many of the companies that are product companies is that the bill of material gets changed at the last mile of the project. Somebody in the financing decided that let's take this cheaper component, and that destroys the user experience. So the frames per second goes down or something else. So we can help in scoping that right, from the beginning of the project. And then the big part, what we do with the MCU, is that because Qt is so big animal. Qt has a lot of features and functionality and libraries. We have to be picky what we put on MCU. So this is a work in progress. It's not a final chart, but this is the things that we know that we can support, things that we know that we can support, but with limitations, so the whole thing will not be there. And then things that we know that definitely will not be there on the MCU. So, and there are a couple of obvious things, like the Android libraries, they will not be there. So, and this is also something that, because the customer projects are different, that we will enable the bits that are needed by your project. So that is also a way for saving memory and making sure that there is the right performance in the solution. And this is going to be my last slide before the Q&A. So the normal cycle with the MCU is that first we do in the customer, when you are in the concepting and prototyping phase, we'll do a proto UI for you. That's a short stint. We take what you have, we run it on MCU, and with that we can both scope the amount of work that has to go into the actual project, enabling all the previous things that I handled in the previous slides. And when we have done that, then we actually kick in a project and we do those things with you. And in the end, you buy the distribution license, and then we do the maintenance and support for the next release and update. So I think that concludes that bit. Zolt, microphone magic.
I was a little bit surprised that I have no 10-minute sign. I have just 5-minute sign. But actually, we saved some time for the questions. So please, I will fly there with the microphone. Please raise your hand when you have the question. Okay.
Yeah.
Don't forget it until I'm there. What's that? Can you press that?
Hi, my name is AJ Fernando. I'm from Holoflot. I have a question about what is your approach towards delivering atomic updates over the air?
Yeah, well, that's really not part of this one. We do have a small feature to supporting all the LTA of support Qt. So we can support updating the Qt framework and the application, but it's the client-side bits. So the server-side and the cloud-side bits, you would have to build yourself or buy from somebody. Typically, if customer wants us to deliver the OTA solution, we partner with somebody who actually is doing that on their business. And then we make sure that that integrates with the Qt application. So that's how we do it.
Who would be these partners?
It depends on your requirements. Because your requirements are so fundamentally different if you have 20 items that need updating versus if you have 20 million. So it really depends on the security and what you need updating. Is there firmware? Is there secure elements on the hardware, and so on? So this is going to be a long discussion, so I suggest we take that off, and we can discuss that. I'm going to be on the MCU stand on the demo area. So.
Thank you very much.
Yeah.
Hi, I'm Tomislav Lugaric from Rimac Automobili. I'm curious whether you plan to support the Qt safe render on MCUs.
That's a good question. We've been thinking about that, not for now. So, but if you really want to do it, let's start the project and we can get it done. We know that technically it can be done.
Thank you.
We've been more focusing on the generic Qt QML cases, but if that's what you really want, let's look at it.
So feel free to have more questions. We have enough time. Please, in the front, raise your hand if you have questions to MCU, scaling down. Anyone? Okay.
So if you have more questions, you want to see those demos, I'm in the demo area during the break. Let's have a chat, and we'll get it from there.
Yeah, if there is no other questions, then that concluded the MCU presentations. Thank you, Santtu.